Energy review problem number 20. This is the third in a series of summary problems that deal with energy. They all deal with a Honda FCX Clarity that's burned a full tank of gas, and then gas being hydrogen, and then all of that water which got produced out of the tailpipe was condensed down to room temperature. And that's what this third problem deals with. It says how much energy was released when the steam was cooled to room temperature. Well, as I calculated, it's quite a bit of energy. Let's find out. Uh, we write a balanced chemical equation for the combustion of water, and we then want to calculate how much energy was released. Well, let's see. We just need to know how much water we were dealing with, and we found out in problem number we did in problem number 18, we found out that we were dealing with 1,000 grams worth of hydrogen, or 500 moles of molecular hydrogen. We'd like to know how many grams of water that is in order to do our three-step calculation where we are bringing this down from 120 degrees, see that, to room temperature 25 degrees Celsius, we're going to assume. There it is. And that means it has to go from 100 down 120 to 100, then it has to condense, and then it has to go from 100 down to 25, a three-step calculation that requires the mass of water involved. We do know the mass of hydrogen, so this would be a mole to gram problem, which is two steps. You start with 500 moles of hydrogen. Anytime we have a mole of hydrogen, it produces 1 mole of water. See how it's 2 and 2, the same as 1 to 1. And that's 18 grams for a mole of water. Therefore, we are producing 9,000 grams of H2O, even though we only started with 1,000 grams of H2. There's a lot of oxygen in there, mass-wise. Okay, we know how much water we're producing. 9 kilograms of water will exit this thing as steam, and it all is getting cooled down quite a bit. So we go from that 120 degrees down to 100. We can figure out how much energy is involved there by using the heat formula, Q equals mc delta T. The mass is 9,009 grams roughly. The specific heat of steam is not given here, but I looked it up, and it's 2.01 joules per gram degrees Celsius. And the change in temperature is 20 degrees. That says 20 right there. Multiply them through, and you find that this liberates 362 joules of energy. Now it's going to condense. It's at 100 degrees, it's steam. It'll turn into liquid water. For this, we simply know that there's 2,260 joules of heat energy released when this thing condenses. And so we have 9,009 grams, quite a bit, and every gram releases 2.2 kilojoules, so that's a lot. This multiplies through to over 20 million joules, so that's a lot of energy you can obtain by condensing this stuff down. And then we go from 100 degrees down to 25 degrees. Once again, we use Q equals mc delta T, which I didn't write, but it's up there. There's your mass. There's the specific heat of liquid water. There's the temperature change. 100 minus 25 is 75. You get an additional 2 million plus joules from that. So we totaled them up. This is a small time player here, less than a half a million joules. This is huge, more than 20 million, and this is pretty big, more than 2 million. And you total them up and you get about 23.5 million joules will be released, right, when you condense this stuff down. That's a lot of energy. This is problem number 20 in the energy review unit.